Hello, everyone, and welcome to another episode of Solving Advent of Code in Rust. This is Luciano
Roberto?
and Eugen there.
Yeah.
So, if this is the first time that you are seeing this show, basically what we do is three software engineers trying to learn Rust. And we decided to do that every week by meeting here and trying to solve Advent of Code challenges. If you don't know, Advent of Code is a challenge that happens every year during the Christmas period. And it's coding challenges. It's kind of like a story, and you basically solve exercises to progress through the story. We have been doing this for a little while now, and you can find all our exercises here in this repository. But also we have recordings of the previous episodes on YouTube, so you can check out the channel description here on Twitch to find the YouTube link. So that's basically it for the introduction. Unless I am forgetting anything, feel free to let me know. So what we did last time, and it was a little bit ago because then we went on holidays. So it was exercise number 15, which was something about building a sequence of numbers and then having to be able to calculate the next number in the sequence. And this sequence will go on. And I think the first part was about 20 numbers. The second part was like 30 million numbers. So we did a solution, but this solution was particularly slow especially for the second part, the 30 million one. And then later on after the stream, we figure out a different solution, and we have a PR that we want to discuss. So let me share my screen. And basically what we did in the first solution, I'm not going to go too much into details, but basically we were using an Hashmap to keep... So the game was working, if I remember correctly, that you needed to keep a reference if a particular number was already in the sequence, because before deciding the next number, you should check if the previous number was already in the sequence, something like that. So basically we kept an Hashmap to essentially count the turn of a given number in the sequence. So we could use this Hashmap to see if the number was already in the sequence and if it was extracted in a particular turn. And apparently it turns out that using an Hashmap is not necessarily required. And of course there is a cost in using an Hashmap, because every time you are checking something, you need to hash again, and then you are looking up in the memory. We realized that since we have a contiguous sequence of numbers, for instance, from 0 to 30 million, we could allocate an array in the heap with essentially a cell for every possible number. And then in that index, we will store the turn of that number appearing in the sequence. So go ahead. Yeah.
Something that I want to say about hashmaps in Rust is that doing some research, I found out that there are libraries that implement simpler hashmaps, because it seems that the normal hashmap of Rust is slow into do the hashing. So the hashing is slow. And this is impacting the performances of hashmaps, of the standard library hashmaps, I mean. Instead, there are other libraries for hashmaps that they say that they are faster. I didn't try them. I just read about it. And so one of the problems could be this being slow. And this solution instead is just using an array, a very big array, but an array. And in that way, basically, you are doing a very sparse hashmap with a hash function that is one-to-one.
Exactly, yeah, because we know exactly the index, and that index is going to be the position in memory in the array. So there is effectively no hashing of the value. So basically, this is the whole change that we did. It's converting that hashmap into an array. And here there is an interesting trick that allows you to create, allocate basically an array of a particular size on the heap. Of course, this is something I looked it up because I didn't know. And another interesting thing that this is just for fun mostly. Like we didn't really have to use this, but one of the newest features of Rust is something that is called cost generics. So when you allocate an array, you need to have the size already predefined. So generally you cannot have like a variable here. You need to specify a particular value. Except if you use const generics, this value is something that is going to be known at compile time, because every time you call the function game, you need to provide this generic argument, and then the compiler is going to make sure that that generic argument is turned into a constant at compile time. Or at least this is my understanding of cost generics. It might not be the most accurate, so let me know if that is not accurate and if I'm missing something. So this is basically a way that we used to generalize between the first part of the exercise where we needed to allocate 2020 positions in the array, and the second part of the exercise where we were allocating 30 million. So this is just something interesting that only recently you can do in Rust. Only I think in the last 6 months or 1 year, like it's a new, relatively new feature. So these are the only changes, and I don't think we have benchmarks right now, but this, if I remember correctly, was significantly faster, more or less in the order that we disabled these tests because they were taking 3 minutes each or something like that.
30 seconds, I think. But yeah, still 30 seconds is a lot.
Okay, maybe it was taking 3 minutes to run all of them or something like that. Here it takes, I think, 1 second or less to run all of them. So yeah, there is a very noticeable difference in performance. So I don't know if you guys want to add anything, or if you have questions, feel free to write down in the chat. I'm going to merge this PR and then we can move on to the other.
Before merging, if you want, we can add the benchmarks, run them in main, then you merge, then we run again, and we can show that there is a difference in performances.
Okay, but maybe something we can do and then discuss, do it offline and then discuss the difference in the next episode. What do you think? Or do you want to do it now?
As you want. We already have benchmarks, so it's not a very time-consuming activity to copy and paste them.
So
but it's fine if we do that.
What if we go in this branch and we just pull from master and commit again? Is that should include all the benchmarks, right?
But there are no benchmarks for this exercise now.
No, there are no benchmarks in the main branch for this one. So we have to start to write them there, and then okay, we do that offline and we do that next time.
Cool, sounds good. Then I'm not gonna merge. We're just gonna switch to the other exercise. Eugen, did you want to drive for that one?
Sure, I'll do this one.
I'm gonna stop sharing.
Let me share my code editor. Screen sharing tips. Thank you, application. Where is it? Rust Advent. So, can you see the screen? I hope it's visible.
I need to add it to the stream. Now, yes.
Coolio. So, this is exercise 16, which...
I'm
going to ask the usual annoying thing. Please make it bigger.
Zoom in. Yeah, sorry. No, that's a very good point. Is this okay, or should I zoom in more?
I think that was readable for me. Do it just one more, and maybe close the debug terminal.
Yeah, let me do that. Cool. There we go. So this should be this is actually better for me as well. Maybe I should wear my glasses. That's an idea, I think. Right. So this is exercise number 16, which some of you may have seen. I definitely have not. So I don't know if I want to go through the full description, but let's get at least a little taste of what it is. So as you're walking to yet another connecting flight, you realize that one of the legs of your rerouted trip coming up is on a high-speed train. However, the train ticket you were given is in a language you don't understand. Yet another one. You should probably figure out what it says before you get to the train station after the next flight. Okay, I remember now because I actually did some modifications for this README. So we'll go through the rules for the ticket, we'll look at the examples, and then we'll try to think about how to solve it. So The rules for the ticket field specify a list of fields that exist on the ticket and the valid ranges for each field. So essentially, we're going to have a range of numbers for each of the fields. So a rule like 1 to 3 or 5 to 7 means that the fields in every ticket is named. Under that name is going to be between 1 and 3 or between 5 and 7, basically, inclusive. So this means 3 and 5 are both valid in the field, but 4 is not. So it's 1, 2, 3, 5, 6, 7. Pretty obvious, pretty simple.
Yeah,
Right?
I think even if you had 8, that wouldn't be valid anymore, right?
Exactly.
Only if it matches one of the two ranges.
Exactly. 0 is invalid, 8 is invalid, 4 is invalid. Each ticket is represented by a single line of comma-separated values. So we're basically just going to get the numbers. If we take a quick look at the input, which we have here. Is this?
Your ticket, line 23.
Yeah, there we go. So, okay, so we're probably going to need to skip the first bit for exercise 1. Maybe, we'll see. Okay, so these are basically going to be the numbers. Oh no, these are going to be the ranges, I think.
Yeah, these are like the rules for every field, basically.
Okay, fair enough. So these are ranges for potentially any one of these. Cool. Let's keep reading and see if it gives us anything else to go on. So the question mark represents text in a language you don't understand. Yes, it does. The ticket might be represented as 101, 102, blah, 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 blah. Of course, the actual train tickets you're looking at are much more complicated. Thank you. In any case, you've extracted the numbers, that the first number is always the same specific field. The second number is always a different specific field, and so on. You just don't know what each position actually means. Okay, so this tells me that each position in our input is consistent. So this is always going to be column 1 for each line, correct?
Yeah, but we don't know which field it is, so it's not the first field we see in the rules. It can be any of them.
Yeah, it's just the inputs are consistent among themselves, but not necessarily with the ranges that we get. Okie doke. So start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. Ignore your ticket for now. Okay, so if we have the following notes, 1 to 3, 5 to 7, 6 to 11, 33 to 44, 13 to 40, and 45 to 50. We have these tickets. I'm not going to read them because you can just check them out later. It doesn't matter which position corresponds to a field. You can identify invalid nearby tickets by considering only whether tickets contain values that are not valid for any field. Okay, so, sorry, in the example, the values on the first nearby ticket are all valid for at least one field. This is not true of the other 3 nearby tickets. The values 4, 55, and 12 are not valid for any field. Adding together all of the invalid values produces your ticket scanning error rate. Okay, so basically we need to parse our input, figure out, basically combine these ranges together, I think, to get the valid ranges, then go
for the first exercise, I think we can combine all of them together, right?
Yeah, that's basically what it says, is we need to find out which values are invalid, right? Adding together all the invalid values. Okay, yeah. So we need to find which of these numbers down here is not within any of these ranges. And then add them all together, and that's our result.
Yeah, if I can suggest something in terms of, I mean, because I had a quick glance at the second part. So if we do the parsing in a little bit more generic way, probably we can reuse it also for the second part. And my idea was that we write like a generic parser that produces the 3 different parts, where in the first part is like an Hashmap of rules. So where you have like the rule name and 2 ranges for every rule.
Okay.
And then we have essentially tickets that are just sequence of values. And we can have our own ticket and a list of other tickets. And then I think if we have a function that parses all the input and give us this data structure this way, then we can easily implement part 1 and part 2 just using that data with that structure.
Okay.
Does that make sense? Or
yeah, it does. It does. Okay, so basically we're going to parse these into a hash map.
Yes.
And this separate from these.
Yeah, first part say that we don't have to take our ticket in account.
Yeah.
We just have to skip it for now. And then parse the second one. And then start looking if the number are in any of the rule. If they are not in no rule, is an invalid number.
Do we want to do this in a nice, smart way, or do we just literally want to take the first 20 numbers and push them in a hash map?
I think either or will work.
But pushing them in an hash map is fine. In the end, it's an hash map with a string and 4 numbers because they are all the same format, right?
Yeah.
Yes.
Okay. So let's start by getting that into a hash map. Okay, we have the input. So let's, what do we call it?
Do you want to do it in the function part 1 at the top?
Whoops, sorry. Yes. You can tell I haven't done this in a while. All right. What do we call this? So what are these things? These are basically the ranges, right?
Rules, ranges.
Rules makes more sense. How did you do Hashmap? Hashmap.
Tommaso is already writing in the chat from string.
From string.
I have to highlight this.
Oh, yeah. You're absolutely correct, because we used to do this. And I should remember.
Tommaso is our guardian angel of the from string.
Absolutely. We did it in exercise 14, if I remember correctly. It was a trait, right?
But probably we can also start splitting the input in 3 parts on double carriage return. So you have rules, ticket, and other tickets.
Okay, so input.
Then when we have the 3 parts, we parse the first one with a ruler parser or whatever.
This didn't have split, right? No. Yep. Or did it?
Yeah, I think you have a split. You just need to use double quotes.
Double quotes, yeah, sorry. Does it? Yeah, it does work. Okay, cool.
It should give you an iterator, I think.
Yep.
So you can either collect or keep iterating.
I'm not sure what I want to do. Sorry, I was thinking more about the other stuff.
We need the first. I don't know if you can assign the iterator, then doing iterator.first, and the last for now, so we can do dot last. We don't need our ticket in the first part.
Yeah, so exactly. So
we don't
care. Let's just get. I think no, it was just like this.
But there is not the.
No, you can do dot first. Dot
first. Oh yeah, because it's an iterator, correct.
And then you need to unwrap, I think, because it might be just empty, or you might never find that. Why your Rust analyzer is not working?
I don't know.
Is the Rust analyzer still on holiday?
Yeah, maybe.
Let's see settings. Let's see it. Was it here? You could see packages. No. Sorry, I'm not super familiar with this. Rust analyzer. Oh, because it's
installing. Reload required. Okay, maybe it just update itself.
Okay, I'm going to reload.
Reload, yeah. Don't worry.
Sorry. Oh, it hasn't stopped sharing. Nice. Or at least here it says it's still sharing.
Yeah, it is. It is.
Failed to install support for live share. Okay, doesn't matter. And MyPy doesn't matter either. I mean, it matters, but tomorrow. Okay, and if I remove the unwrap, is it going to complain?
Okay, and now it's not liking the input. Oh, because it's called underscore input there. Just remove the underscore.
Exactly.
Yeah.
Okay, now we are seeing the type infer.
Okay. No method found for.
Oh, I think you might have to do .iter.
Okay, we'll do that. Do we need to do that though? Like the split might have some cool stuff on its own. Let's see. As iterator.
I think you need to read.
Yeah, it was worth seeing if it gives us anything. Okay,
Ooh, we have a new follower. Thank you, Manolia.
And now he's not happy about ITER. On the line
Probably.
2.
It might be 2 ITER.
No method name it.
Okay, we don't know how to split anymore.
We don't know
Integer.
after 1 month of holiday, we don't know how to split a string.
That's it.
Let's wrap up. Go.
For structs. Why is it still a split? It should be an iterator now.
Save? No.
I have saved. It's still seeing it as a split. Interesting. Okay, let's look it up, right?
So split returns an iterator. Iterator as next. Just try to call
Just
next,
next.
rather than first. Yeah. Cool. Thank you, Tommaso.
And number. And now unwrap.
Cannot borrow is okay.
And also you have to borrow it because otherwise we are going to destroy the.
But this is.
You must be,
you need to declare the split as mutable. Yeah.
Makes sense because I am consuming it. Okay. Rules, own ticket. Did we do camel case or did we do snake case? Jesus, I forgot everything.
Snake case.
Sorry. I'll just do this and let other tickets. The same thing. I know this is dirty. We'll make it prettier later.
On line 4, put an underline in front of the variable in front.
Okay.
No, in front of the variable name in line 4. Put an underline because we are not going to use this variable. So
yeah, fair enough.
In this way, I think he's not complaining about an unused variable. Otherwise, he's going to complain.
True. That's a good idea.
Fair enough. Okay, so now from string, which we've used before, and I'm going to just look it up because I don't unfortunately remember. Oh yeah, we needed to define a struct. Makes sense. Okay, rule. Do we call it a rule?
Yes.
Or do we not call it a rule?
So we could use, I think Rust has a concept of ranges. I think it's called range inclusive or something like that. We could do like a tuple containing 2 ranges, and that will be our rule, right?
And the name.
But we need the name as well, right?
And the name, it's only that either we keep in an Hashmap, or what do we want to do? Do we want to do like
I want to keep the rule as just.
The only reason why I'm saying that, again, I did a little spoiler and I checked part 2. And if I remember correctly, in part 2, we'll just need to pick some of the rules at the end, like the ones starting with departing or something like that.
Okay.
So being able to quickly get all the names and filter over them will be convenient, I think.
Okay. So this is just going to have ranges of range. Is it the thing? Yes.
Range inclusive, I think there is something.
Yes,
I think
I can see it. Yeah. Okay.
And you need 2 of them. Range inclusive, I think we might have to say what? U8. U8 probably.
Are we sure 8 is enough? Because we don't know how big the inputs are, right?
Let's check.
Do we fit? No, we don't fit in U8.
For 9, no.
No.
So
okay, then U16 probably.
Yeah, that should be enough.
I'm more confident.
And you can repeat this twice because we need 2 elements.
Correct. Okay. Okay, and then we implement rule from str, or was that not?
You need to implement from str4.
Yeah, okay. Yeah. Sorry. Okay, and this was fn from str. There was another thing here.
Oh yeah, now I'm seeing the problem with the name if we implement it this way, because
We
we
are
are
losing the
parsing an
name.
entire line.
Yeah, exactly.
So let's also have a name there in the rule.
You can have the name inside the rule and then create an hash map with the name also in the key.
Yeah, exactly.
Okay, we are replicating a little
So
bit, but
how
it's
are
not
we
going to
doing
kill
this?
anybody.
It was just getting a reference to an str, and it was returning results.
Copy the full line is fine.
Hmm.
And also the type R declaration, not that is hard to write, but
No, fair enough. Makes sense to not bother. And this is not going to be mask. This is going to be line, basically.
Exactly.
Okay, so the line.
Now that rule str, name str, I don't think is gonna be valid. I think it's easier to just use a string with uppercase S in line 4.
Ah, okay.
Otherwise, you have to use a string slice and then deal with the lifetime. Yeah.
And this needs to be. Does QuickFix know how to import it? Yes, it does. Cool. str from str. Perfect. Okay. Self. Okay, we'll need to deal with it. So, line, we'll also need to split it, right? On
there is a semicolon, I think. Yeah.
Okay.
A column, yeah.
Okay, so split is going to be this, and then name split dot next unwrap. This is very dirty. And
do we want to do with a regex instead, or we don't want to go down that path again?
I don't know. I wouldn't use it for now. Then we'll see if it's too ugly. We can clean up later.
Yeah.
Okay.
Just curiosity, is it always 2 ranges? It is always 2 ranges. Okay, so we'll need to split on... Actually, we'll need to strip the spaces off this one and then split on or, basically, right?
Yes.
I mean, and seeing why a regex... Yeah, and seeing why a regex will be nice because you get all the parts in one go, but...
Yeah, here we are splitting on colon, splitting on or, splitting on dash.
So basically, not colon plus capture.
You can go on regex 101 and we can figure out the right regex.
But I'm not sharing that, unfortunately. Okay.
If we want to go with split, we go with split. We do that.
Yeah, let's do it with splits for now, and we'll do a nice regex later.
So we have a pull request for next episode.
Exactly. Split up next. Apologies. Next. Which we need to again split, right? Oh no, we need to... Does roast have trim or something like that, or like replace maybe?
Next, you always have to unwrap.
Yep. Replace, and this needs to be literal space, right? With nothing.
Oh, yeah, luckily we can do that.
No, wait. Expected enum. Because it's trying to return this. Apologies. Are you happy now? Yeah, okay. Okay, we're replacing this, and then we have to split it again on or, right? If I find it, yes.
Then we have to assign it to somewhere, please, because I'm starting to get lost.
This feels unbearably ranges, unparsed ranges, sorry. This feels very, very dirty, by the way.
I am almost ready to give you a regex.
Just paste it.
Okay, yeah, but I don't remember how to do them. If you remember last time with regex, we had to use the lazy static to create the regex outside of the function and everything else. Do you remember it when we parsed the passports?
Yes, we can just copy it from there, I think.
Oh yeah, we can copy and paste from the passports
this easily. Is terrible.
Like, also because Elgin doesn't know how to write next, so...
Yeah, come on, 20 more times and I'll get it right.
Okay, I'm gonna copy paste the regex here.
It's almost done. Come on.
No, please do. It works, yes?
I am testing here, yeah.
Okay.
You can start search for the passport exercise. Was one of the first, I think, second or first one.
Let me just
And-
do passports.
And there were
Day 4.
Like if people don't believe me, there is a check here.
Lib. Regex new. Okay. So a lot of copying and okay, so let's just store this here. Steal this from here. This will be outside of the implementation, so it doesn't. And I need to what?
I think you have to declare stuff as lazy static or put them that inside the function.
Wait, is it?
That one is inside the.
Oh, this is inside the function.
Search for lazy static around.
Yeah, we use it in some other exercise.
Sorry, roast lazy static. I'm just googling it just.
But in this code base, search lazy.
It's the number 7, I believe. Yeah, number 7. If you look the exercise number 7, we have that.
Certainly. So let's see. Oh, and I probably need to, because it was a library, right? Yeah.
You see that? Yeah, we'll need to use both lazy static and also the regex library. So we'll need to add it in the
correct
cargo file.
You're just gonna
cargo
copy
dependency, those 3 lines.
I think we don't have any for this one. Correct, we do not.
Yeah, we just have the empty session.
Okay. And
also, go to the 7 one to copy the syntax for the lazy stuff. That is line 13.
Yeah, 19. Well, we're gonna need to do a bit more around it, but static line regex. Okay, it's got the same name. And
we can call it rule regex. Probably is
sure. Whoops. And we don't need this, and we do need this.
Yeah, I didn't put the beginning of string and end of string. If you want, you can do that.
It can't be extra cool. So, yeah, but how was it used here? Because it was defined once there. Oh, and it's been used. Okay, cool. So we don't need this.
Actually, I don't think you even need the slash before the column there.
This?
Yeah, I don't think it's needed. Yeah.
Lazy static. Unsolved macro, sorry.
Give it time.
Let me save 50 times.
Also, probably cargo install, cargo update, cargo something.
I can just
I think yeah, there is a suggestion here.
If I run one of the tests, it should.
We need to import the macro from. It was the first line or what? Macro use. You see the line 1 that macro use.
It is not a comment. It is something.
It was commented, so I just ignored it. Apologies.
Yeah. Yeah, because I think we want to say to the compiler that we are importing a macro from another package, which maybe not so obvious.
This was used by capturing the line and unwrap. Okay.
And then then capture this and capture.
Honestly, I can 100% copy this stuff because we're just renaming some of the things. We capture groups this time though. Oh, and this is going to be rule regex. Captures line, it's got the same name. This is going to be the name. This is going to be own ticket.
No,
you will have like.
Oh no! Wait! Sorry. This is
like range 1 start, range 1 end.
Range 1. Yep. Start. Sorry. Nice. It's still rather repetitive. Range 1 end, sorry. And range 2 starts, range 2 end. And this 3, such fun, 4, and 5. Okay, and then we can just...
Now we have to create the object to return, right?
Yes, but we also need to make sure that the ranges are U16.
Yes, because this is string from.
Well, we can try to assign them to range and with a parse and see if he's smart enough to.
Yeah, it should. So if you declare the type U16 for every one of them,
Yep.
then you can, rather than do a string from, I think you can do capture number dot parse and unwrap, of course.
Wait a sec. Number.
No. Just capture 2 will be an str.
Okay.
With the ampersand.
Yeah, because it's.
I think you need. I'm not sure if you need the ampersand.
I don't
then
know.
just try to do dot and see if you can do parse.
Yes.
Okay, and then probably. You need to unwrap because it might fail, of course. And maybe you don't need the ampersand. Let's see.
Mismatch type x. Found reference.
The ampersand.
Yeah.
Perfect. Okay.
Okay, let's just redo this.
Ooh, we got a raid.
Oh, nice. Hello, people.
Thank you. Hello, everyone. Now we are seeing the chat. Yeah, sorry, we are a little bit slow.
Apologies. Yeah, we were busy copy-pasting code. Hello and welcome. Quick, write and save first when they're not looking. Yes, exactly. Okay, so we have all of these things and we return a rule which was done how? Because we have one of these
curly brackets, and then you specify all the fields.
Okay, name.
By the way, I'll give a quick spiel to the new people. Basically, what we are doing is trying to learn Rust by doing Advent of Code challenges. So that's why you see us doing all sorts of weird mistakes in Rust, because we are noobs and we are learning. So you can help us if you want. Feel free to write in the chat if you have any suggestions. Oh, nice. We have another friend here doing Advent of Code. Please send us the link later.
Please do. Sorry, I'm just trying to make this a little bit readable. Okay, it's unhappy with this.
Because we have to return a result, I think.
You need to say okay rule. Okay
rule.
So just write okay.
Okay.
Uppercase. With uppercase O.
Okay.
And then parentheses and wrap everything.
Yeah.
Wrap the entire rule.
Gotcha.
And K is lowercase.
Yep. Sorry.
Yeah.
Because otherwise
you have to give back a result that can be something or an error.
Or an error, yeah.
We are not doing any kind of check. We believe the input is always perfect.
Yeah.
Yes, and we unwrap a lot. That is not good, but we are noobs, so it's allowed.
Also, the input is static and it's here and we know it's valid. None of this code is reusable anywhere because...
Yeah, and it's not very defensive programming. It's more hoping programming.
Yeah, it's exactly hopeful programming. It's like, I know the input is fine. I'm sure of it. Please let it be fine.
We can go back to part one now.
One thing that we can do later, if we have time, is to show how we can use the question mark operator to remove all this unwrap. But that's an entire conversation on its own. So we'll leave it for now.
From STR?
No. That one is... Okay. Let me think.
Oh, wait.
Because
That's
we
not what we
have
want.
we have to iterate line by line on that big string. Or the rules right now is a big string with a lot of lines. We have to split by line, and every line must become a rule with our
Correct.
from string.
Correct.
And also we have to skip the first line, I think, because the first line will be the first line is fine. Let me show.
No, first line is
No, the
actual.
first. Okay, no, fine. Don't listen to me. We just have to take and parse the rule, iterate them line by line. That I don't remember how to do it. So
there
probably
is a dot lines.
dot lines dot map,
Mm-hmm.
and this will go inside a.
What we wanted to make a hash map though, and use the name as a key, right? That was the idea.
We can do that later in part 2.
Yeah, let's just do a list for now.
I don't know if it's needed in part 1.
So rules.
To be honest, even in part 2, we can go through the list and filter. I mean, it's not 1 million elements. It's just going to be few elements.
Okay, so we're mapping and we're giving it rule from str with an underscore, basically.
Then we have to collect.
Let's see if that syntax works.
No. Yes.
I think you have to declare the type as a vec of rules. Otherwise, it's not gonna be able to figure out what are you trying to collect into.
Rule. It's cannot be built.
Oh, because that from str will fail. So you basically have a vec of result rule this way. So one way you can do this, we can pass a closure. So you can pass like a pipe.
There was not a filter map that was taking only the one that were not error? No, it was. Good point.
Was it
do
filter
that.
Map? No.
Look at this guy that is always helping us. Thank you, Tommaso.
Thank you. Okay.
But there was also filter map.
Yeah, because when we do filter and map or otherwise, they always tell us in the comment, I'll do filter map.
And it's still unhappy. It cannot be built from an iterator.
Because it is still a result, even if we filter the one.
Over it or amp over it. Jesus, I really can't type today. Apologies. Wait, how do I get the actual value from a result?
Let's unwrap like there is no tomorrow. Let's just do a map like Luciano was saying. You remove filter and the second map, you just do a closure in the first map, and
then we make it nicer in a second.
Yeah, then we do good stuff, good Rust. Next,
hang on, because I forgot syntax. I forgot everything. I apologize.
I can tell you the syntax. Don't worry. So basically, between the pipes, you have the arguments of the closure. So just call it L for line, for instance. Yeah. Then space, and you can say L.parse. No arrow. Just say L.parse, parenthesis, dot unwrap. And then parenthesis again. And that should do it. It's not nice, but whatever. Should work.
Seems to do it.
Okay,
we have the rules. Yay. Now to do the same for the other tickets, right?
For other tickets, we just have to take all the lines except the first one. The first one will be a test.
Yeah, the first one we have to skip, and they're basically vectors of numbers.
Yes, so we
can. Or do we want to make... go ahead.
We can do a split on comma for real this time, because it's just one split and on...
And we just use it as a split.
We can go to a vector of numbers, can't we?
No, we can use it as iterator. That's what I'm thinking. We can just keep it as a split, and as we iterate, we store the failed, right?
Okay. But at this point, we need a vector of failed numbers.
Yeah, exactly. Vec of U16s, we said they are. If I would maybe name it. Numbers, and actually we don't even need it to be a vector because we need to add them. So this is just going to need to be a very large number. We can make it like a new 32 to be sure.
We can just use an accumulator. Yes. Okay.
Jesus. Sorry.
Starting at 0.
0, yeah. Okay, cool. So now we can go other tickets. Next.
But we can do 4. We can do a 4 ticket in other tickets, skipping the first one. I don't know how to do that.
There is a skip one, I think, if you want to just skip the first one and then iterate. I think you can do .skip.
I do remember we used skip before. Let's look through. .skip. Ah, frick. Wait, what did I do? Search again. Please. Where was it?
We have before first stuff others.lines, because others is other ticket is a string now. You don't have.
Oh yeah, we need to do .lines first, right?
Yeah. No, not there. That was fine. Other tickets.
But we're not storing
because
them, man.
Other tickets .lines.
Ah.
Okay, that will give you the
one.
Okay.
And we do a 4. And we do a 4 line. Oh, if we can do a map, we can do the normal 4
each. Yeah.
Okay.
So this is going to give us a line that we do what with?
We have to take the line, split on comma, iterate on over all the elements that we get back from that split.
It's gonna be terrible to read, but yes, we're doing that.
I was suggesting using normal for that, just instead of the functional way, the normal way, because it's 4, 2 nested 4, nothing.
Okay, so for ticket in other tickets, colon or
just purely brackets, yeah.
And now, if you want, you can do 4 number in split this and that.
In ticket split, blah blah.
But you need to
make it. We have to make it a U16 somehow. We can do that in line 50.
Yeah.
Let n type U16 equal to number.parse.unwrap.
Yep. Okay, and now we need to check it against each of our rules.
Now, for all the rules, we have to check n against the ranges in all the rules. So there is another 4.
This seems inefficient. It might have made more sense, instead of storing the rules like this, to store less ranges, because they probably overlap.
Oh yeah, that could be an optimization
but
for
we'll
later.
Optimize it later.
It can be a second optimization. Probably there is in Rust a way to merge.
So how did we call this?
Range inclusives.
Okay.
Even though I think for the second part of the exercise, that will be a little bit of an overkill, because in the second part we'll need to find fields based on ranges. So we'll need to retain that information of individual ranges, or at least individual rules.
For that one, but for this one, there's a different, as in it makes more sense here to merge them into bigger,
it would be more efficient for sure.
Yep. When we have a green test, we can go with refactoring.
Exactly.
So, here you can do a 4 rule in rules.
Okay, yeah, fair enough. We're door 4 rule.
In rules.
I was going to do something else, but okay, for rule and rules, if an how do you actually rule dot?
Rule dot ranges square 0, because it's the first element.
There's 2 of them. Yeah, I wanted to get one of the rules and see if it has anything.
There is an operator in.
There is a suggestion here.
Is there? Rules that are find. Yeah, that's what I wanted to do initially. Thank you, Tommaso. I wanted to find the rules which don't match this number, basically.
You want to find the rule
but no,
that
we need
is
to
not matching, and when you have it,
you add the number to failed numbers.
And instead, if you don't find anything, it means that the number is valid.
Yeah, it just continues.
Okay, I prefer your way.
For now, we started this way. Let's do it like this, and we'll do it later. So,
but it's also less code to write in that way.
That is true.
So I prefer your way.
Enter, filter.
It was not find.
Find, sorry. We can actually, yeah, because find will find the first one, I think, and that's what we need, right?
If it is one is enough, I mean. Why that one is a double reference?
Because of the iterator, I think. I can... No.
No. If we can do dot range on top of that beast, I'm fine.
We can.
So
but now we
I'm
need to
perfectly
figure out
fine.
how we actually use the rule.
I think there is something like contains in ranges. Let me see.
I hope so. N? No.
Try adding a semicolon. Okay. Yeah, let's write it and see what it says. I don't think it's going to be.
There is dot contains.
Wait. Because it's a tuple.
Do dot zero instead of square.
Oh yeah, rather than the square brackets. Sorry.
You're right.
This is.
And then you need to pass ampersand n because it's looking for a reference.
Correct.
Okay. And we'd have to do that.
Or was it pipe?
I think it's pipe in.
So I've been doing almost exclusively JavaScript and Python over the last
another nice optimization for later will be to have a struct function where we can say check a value against the rule.
Exactly.
Okay.
But so, let's leave it for later.
So if one of these, basically, Jesus, this is terrible.
We don't have to do if let variable sum of that.
Yeah.
Or, I don't know. I am asking.
Actually, we can just store this as a variable.
So find will give you some value, right? So you can store it for now, and then we can inspect it in another line.
It's an option. Option of rule. Okay, so then we check if it's okay or not. Basically.
If it is okay or not, we have to find if that option is empty or if there is something in it.
Then you can just say is okay, basically. Found is okay. Yeah. Or is some, sorry.
Well,
actually,
we have to
care about if it's
we
none.
Care exactly. We care about if it is
if it's none. Yeah.
If that is known, then we add the current number to our accumulator.
Yep. Can we do this? We can. Beautiful.
So basically, just for me to recap, what we are doing is
return failed numbers now.
I will now. Just a sec.
So what we are doing is basically given a number of ticket. Well, given a ticket, you have numbers. For every number, we try to find the first rule that matches. If there is none, it means that that number is invalid. So we accumulate that invalid number.
I don't think we need to use find here.
Why?
Because find will return the first rule that matches. We want the first rule that doesn't.
Yeah, but that's good, because if it finds one that matches, it means that number is valid for at least one rule.
Yes, but it might be, as in, it's going to stop when it finds one that matches.
Yeah, but if we found one that matches, the number is valid.
So we don't need to accumulate
Correct.
This
You're absolutely right, sorry.
This is an or, not an and. We are not looking for a number that satisfies all the rules. We are looking for a number that satisfies at least one rule, and then we have to take the others. So the one that doesn't satisfy any rule. Okay, yeah.
You're absolutely right, Roberto. Apologies.
Boolean logic is hard, like dates.
It's really hard.
In all the stuff we were doing. Okay, so we are returning the number. I guess. Well, wait. This is unhappy about something. Unexpected.
Are we missing a semicolon somewhere?
Are we? We have an extra round brackets at the end of that. Yes. There was an extra round bracket.
No, wait.
No.
Cannot
that's not mutable, right? Or did we make it mutable?
it's U32 because we didn't know how big the number is going to be. And this
Yeah,
is
Okay, so
U16.
just do n as U32 there in line.
Ah,
Without the dot, just as.
And also is mutable, failed numbers. I don't remember. No, you have to make failed numbers
it's
mutable.
expecting U64.
Oh, because that's what we declared there. That, I mean, you can change it.
But
No.
is this number a U64 or?
In the previous function.
So
I think
part 1. Yeah, the return here, U32.
Yeah, make mutable, that value mutable.
Which
In
Okay,
line
now it's
47.
complaining. Fair enough.
That's correct, yeah. Okay.
Let's try part 1.
See what happens. Probably gonna... Field is never read. Okay, that's fine.
Because it's useful for the second part, not for the first one.
Correct.
Green.
Okay, it passed. Nice.
Nice. Good job.
Nice. For as terrible as it looks, it works.
I take a minute because I have to stop a peeping in the background because there's something
No worries.
making noise.
Yeah, go for it. Heard it as well. Okay. So this
Also, since I have only 10 minutes for today, I suggest we maybe try to leave it at part 1 and maybe spend the next 10 minutes to make it a little bit nicer. And then we'll do part 2 next time.
I was going to suggest we merge the ranges for this part.
That can be more than 10 minutes, I think.
Yeah, that's fair. Okay, what should we make nice then?
So we mentioned a few things. One, that we could create a let's call it a method, even though maybe it's not the right terminology. But rather than do it that find with that closure, we could have just rule.matches and we pass a number.
Oh yeah, that makes perfect sense.
So we can implement a function in rule, basically.
So we need to do an implementation of rule.
And rule.
If I could type, give me just a second. Jesus, there we go. Matches or
on the range inclusive is called contains. So if we want to keep the same terminology,
good suggestion. Yeah,
we go with contains.
Do we want to call it contains? Because it's
I like it.
Fine. Okay, and this returns a Boolean. Do I do it like this? Yeah. Okay.
And it takes a U16.
Bool is lowercase.
It is lowercase. Apologies.
Is it? No, I'm not sure.
We'll find out.
We'll find out.
True. Let's have
it.
Okay, so we're getting a number which is a U16. And we return, let me just copy this weird thing.
Exactly, we can copy all of it. Oh, you also need to use self as a reference in the first argument.
Will do, but let me just find it before. There we go. And it's
and you need to put the ampersand, otherwise you will consume yourself.
Yep, self.ranges.
And also self.ranges there. And that should be it.
Yep.
Now it's complaining that we are never using this guy.
That's fine.
Isn't better that we, instead of taking a U16, we take a reference to a U16? So as general rule, when you...
we should mention this as a reference.
Probably, yes.
We don't want to consume it.
And now you probably don't need to pass the ampersand when you call the contains function. Like, not there, yes, in the other, like inside in our implementation.
Because it's already a reference.
I don't think we need that. Yeah. Let's see. Yeah, shouldn't complain. Cool.
Okay, let's run the test and see if this worked. Okay, that's still not used. It will be next time. Yeah, it works. Yeah, I do like this much more. I don't remember who suggested it, but thank you very much. I do prefer this. It's cool.
Okay, then what else can we improve? There is a lot of unwrap. In theory, it's a little bit nicer to use expect. Because
what was the stuff about the question mark you were talking about?
So let me finish expect. Expect is basically like a wrap, so it's still gonna panic, but at least you can define the error message. So for instance, here we could say expect couldn't find the beginning of the range, or maybe the beginning of the range wasn't an integer, something like that. Yeah, so basically, if it fails, at least you have an indication on why it did fail. You don't see just a random panic.
So like beginning of first range was not found or not an int, this kind of stuff.
So this is still a little bit dirty because you are still panicking, but at least you know why you are panicking. Ooh, we have a guest.
Yeah. Next time she drives.
Hello.
Okay, so that's one thing. The thing with the question mark is basically when you have a function that returns a result, every time you have like in the body of your function, every time you have a result, you can just put a question mark at the end of that expression. And what that does is basically like a syntactic sugar to say, try to do unwrap of that specific value.
So this basically? No.
Yes, exactly. Now there is an error. I'll get to that in a second. So that basically is like doing a wrap, and in range end you will get the value. But if it fails to unwrap, it's gonna return a result with that error. So it's not gonna panic. It's just gonna return a result. Now, of course, the issue with this is that you need to have uniform error types throughout all the possible errors, because it's going to try now, for instance, here, the error type is just an empty tuple. And if you fail to parse, the error is something else. It's not going to be an empty tuple. So now the issue that you are getting is that it's like you are trying to convert that specific error from parse, which I'm not sure which one it is, into empty tuple, and it's not allowed. Let's see if that's the case, if you over that.
Oh, sorry. Resolving U16.
Parse int error, yeah.
Okay, so for instance, if we declare our error type as a parse int error, that question mark is going to work. I think.
I think I have
maybe
to
needs to be
right?
imported. Yeah, I think it needs to be imported.
No. Okay. Yep, now it works.
And question, if you know, is possible to declare multiple type of errors that you can return? Or
so what you can do, like short answer, yes. Long answer is that you need to have conversion functions from one type to another. Because at the end of the day, your function always returns one type. So a result of a value and a type error. So you need to have like a uniform type error for that function. But if inside the function you have different types, you can write conversions to that error type. So for instance, that if we wanted to do this in a more clean way, in a cleaner way, it will be rule conversion error, for instance, or rule parsing error. And then we will write a function that converts a parse int error into a rule conversion error. So there is a little bit of playing around and writing things to make it nice. And there is a crate that I think is called anyhow that gives you macro to easily remove all the boilerplate and just specify all the different types of errors you can have and how to convert between them. But yeah, this is one of the topics in Rust that there are a lot of conversations going around, and they're trying to make it easier and easier. I suspect that anyhow crate eventually, or something like that, will go into the standard library because it's just easier to write all the definitions and not to write all the functions.
For now, I don't think we can do this because we have two potential. We have parse int error from here, but we also have the captures error from regex.
Yeah, we will need to create our own struct, like rule error or something like that, rule parsing error, and then we'll need to create the two conversions.
We could do that. For now, I would leave them as unwraps, but this is something we can maybe tackle next time.
Yeah.
as in make these things nice, and then there's a few points of optimization for this to make it a bit quicker and nicer. So maybe we could do that next time, and then when we're done with that, we start with part 2 of this exercise.
Do you want to revert line 25 to an empty tuple, or?
Good point. Thank you. I forgot I did that. I will run the test before I commit any of this.
You can call name, I think, underscore name, if for now you want to get rid of the warning.
Sure, it's a bit nicer.
I'm not sure if we do any linting in our CI.
And also you can remove...
field with a similar exists.
Yeah,
Does
if
it?
you
No, that's because I named it there, but I need to name it here as well.
Oh, yeah.
And you remove the import of the parse int at the top. Yeah.
Correct, because we're not...
If you don't want any kind of warning.
Yeah, let's keep it clean, right? Clean. Well, at least no warnings. Yeah, cool. There you go. It works.
Okay.
Can you... how do you use the terminal in this thing? Because there we go. Okay. So I'll just commit it and push directly, right?
No, wait. What you changed in exercise 01?
That's actually a good idea.
Oh, maybe it's just formatting. Or did you copy paste?
Got doff.
Sorry. It might have been from my copy paste.
You wrote got instead of git.
Ah, Jesus. Sorry, my typing is really bad. Oh, because
You did kill the skip.
How did that work?
Instead of copy and paste, you did cut and paste.
you skipped the skip.
Oh, well, do a git checkout of that file and we are fine.
I think it's good now.
Revert it.
Yep. Okay.
Now you can do a git add all.
Correct. Okay, so this was, year 2020, exercise 16, part 1, solution. Unoptimized, because that's what it is. Cool.
Yeah, even though I would argue that the input size is not that big as in other exercises, so probably it's not that terrible. Because merging ranges, I don't think it's that easy either, right? Because you always need to check how they intersect and then...
Well, how many lines do we have? 263, yeah.
Question, just to see if there is. In the type that we are using, range including, how it is called? The type.
Range including, yeah. Inclusive.
Yeah. Inclusive, sorry. There is a function between two range inclusive to merge them.
Or to just see if they intersect.
Yeah, if they intersect, you can just say that you have a new range that is starting where the first one starts and ending where the second one ends.
Wait, let's just...
I don't see one. There is empty.
Let's see what it has.
Contains into inner and start new. I don't see something like that.
Okay, nothing.
No. Maybe there's a library that does this.
No, well, in the end, there are two conditions. They are not overlapping. They are overlapping like this. They are overlapping like that, and they are overlapping like this. So one is bigger of the second, and you take the biggest one. They are not overlapping, and you have to give back two of them, and they are overlapping because one start is contained in the other, or the end of one is contained in the other. So it is not a lot of if. But if there was already a function doing that,
yeah, it would have been worth using.
Why to implement your own? The problem is that that kind of function would give back one or two range inclusive. So type-wise, or you give back a vector that is one element or two vector or two elements, or you give back I don't know, how can you do?
You might do like enum, because in Rust enums can contain values, and then the two variations are like either merged or not merged. But then it's again on you to do the case, the match statement to figure out.
To be honest, for this case, it might make more sense to have vectors, because you can keep adding the vectors up, basically.
Oh yeah, you can
and
use
just have
vector.
at the end you have just a list of rules and that's it.
Like we have now. Now we have a list of rules. The only stuff is that we have a shorter list of rules. And due to the fact that we iterate over the list of rules with defined, because it's iterating in the end, defined, it's a little bit more efficient. It's true that defined stops at the first that match. So,
yeah, it might make a difference, but it might not be a very big one. To be honest, for the size input, I don't think it's going to be meaningful.
What we can do is, if we want to do for next times, is keeping these like that, writing a benchmark, trying to create a pull request, and when we propose the pull request, the benchmark will run, and you can see if it's faster or not, and more or less how much.
Sounds good, yeah. Sounds like a very good idea. Luciano, you were saying you have 10 more minutes, about 10 minutes ago.
So let's do the closing business.
Right,
so
stop sharing.
Let's see. So what are we gonna say? The usual. Do I have to do it?
Yeah, go.
You can do it. I can do it. I don't have it open.
Go.
All right. So thank you everyone for following this other episode. So we'll continue next Monday, 5 p.m. GMT. We'll continue with the second part of this exercise. Probably we're going to do a little bit more cleanup. Probably we're going to discuss a little bit more about benchmarks on the previous exercise. So the usual is feel free to follow us if you like what you see, either on YouTube or on Twitch. And depending where you're watching us, we do the live on Twitch. If you're watching on YouTube, make sure to check the links. Also, if you're watching on Twitch and you want to see the previous recordings, you'll find all of them on YouTube. So again, thank you very much and see you in the next episode.
Thanks you. Thank you.
Bye.
Thanks you. Bye.